Okay, so we're going to start the second half of chapter 11 deals with not surface area, but volume. So volume is defined as the space that a figure occupies. So we're gonna talk today about prisms. Tomorrow we're gonna talk about cylinders. Wednesday we're gonna talk about pyramids, maybe and cones. Right now it's for Friday. Pyramids is Thursday. Cones is Friday. Then we have spheres, surface area, volumes, and spheres, and then you'll have a quiz. So sometime next week you'll be quizzed on this stuff. All right. Area, surface area measures the outside of a figure. Volume measures the inside. When we talk about area, we use square because we're multiplying in 2 dimensions, length times width. And even though it's a 3-dimensional figure, we're multiplying 2-dimensional sections of that. When we find the area, we're finding a series of 2-dimensional shapes. Volume, we measure the inside. Okay, so the reference sheet does have volume on it. Okay. We were talking about the reference sheet, and we were all pretty much in agreement that we don't like the formulas that are on here because they can be confusing, and you forget how do you find the area of the base. But unfortunately, this is what we're stuck with. And while it would be nice for me to say to you, just ignore the formulas on the reference sheet, it seems to me the easier thing to do is to learn how to use the formulas on the reference sheet so that when you see them, it will make sense to you. Okay, so
Can we put this here on your desk?
yes, you may. Okay, so the volume of a prism is the area of the base times the height. So on the reference sheet, it has 2 different definitions. It has BWH or B capital B times H. Now, when we talk about a prism, how we find the area of the base is obviously going to be determined by what's the shape of the solid. So we have 2 different types of prisms that we're going to look at. We have rectangular. So we have 2 different types of prisms. We have either a rectangular prism or we have a triangular prism. So for the rectangular prism, the base, the area of the base is length times width. And the area of the base of the triangle, what's the formula for the area of a triangle? 1/2 base times height. So you need to recognize both of these. You need to recognize how to find the area of the base of both a rectangle or a triangle because you're going to see both. And again, on the reference sheet just says capital B times H or small b times W times H. So it's important to know what the big B stands for, depending on what prism you're using. In my opinion, the volume of a rectangular prism is the easiest one you're going to find. Why do you think that is? Not because it doesn't have a slant. How many numbers are we multiplying together to find the volume of a rectangular prism? 3. How many numbers do they give us in the problem? 3. So how do we find the volume of a prism? You see the 3 numbers that are there? You multiply them together. The volume is equal to length times width times height. Or, as it says on the reference sheet, capital B, area of the base. But what is the area of the base of a rectangle? Length times width. You take your 3 numbers. Does it matter which one I designated the length or the width? No, it doesn't matter. We're multiplying all 3 together. So, but if for accuracy's sake, I'm going to put them in order. Area of the base is 24 times 20 times the height. Well, 24 times 20 times 10. Just plug those into your calculator. You get 4,800. Here's where you need to be a little more precise. Remember, volume measures 3-dimensional space. So we're going to use not centimeters squared, but centimeters cubed. And I promise, that's it. Okay, now let's take a look at a triangular prism. Slightly more complicated. Okay, so again, the volume is the area of the base times the height. And the area of a I can see they draw this one differently. All right. Okay, so step number 1. Okay, now, what's the problem? What's the problem here? You say you? What? Don't worry now. I'll remember. What do we need in order to find the area of the base? What's the formula? 1/2 base times height. What don't we have? We have the base. We don't have the height. Okay, so here's what we're going to do. We're going to take this triangle, since since it's the base, and we're going to pull it out, and we're going to redraw it. Okay? Because here's, remember, these are going to be the same. So if this side is 8 on the right, then the 8 on the left is going to be the same. Okay, now, what kind of triangle is that? An equilateral triangle, which means that each angle is how many degrees? 60. So this angle is 60, and this angle is 60. So what I need to do is I need to draw in my height. So now, what do we know about each of the triangles that let me make this, who can tell me one way to find the length of the height? You can always use the Pythagorean theorem. Which side of the triangle is this? A squared, B squared, or C squared? C squared would mean it's the hypotenuse. Is it the hypotenuse? It's either A or B. The answer is it doesn't matter. Now remember, when you're trying to find, I taught this to a student while I'm tutoring. When you're using the Pythagorean theorem, if you're looking for the hypotenuse, you add. If you're looking for one of the legs, you subtract. So we use the Pythagorean theorem, A squared plus B squared equals C squared. One of my sides is 4. 4 squared. My hypotenuse is 8 squared. So that tells me that I'm going to subtract. 4 squared is 16. 16 plus b squared is 64. 64 minus 16 is what? B squared is 48. That means that b is the square root of 48. Okay, that's one way to do it. What's another way to do it that I think is easier? What kind of triangle are each of these little triangles? They are right triangles, but they're what? They are 30, 60, 90 right triangles. So what is the ratio of the sides of a 30, 60, 90 right triangle? Which is the hypotenuse? It's 2x. So it's x. The middle one is what? The third one is going to be 2x. The hypotenuse is 2x. The middle one has to be x radical 3. So what is my x in this problem? What's the value? What's the length of this side? 4. That makes the length of this side what? 4 radical 3. Well, we don't really care about the angle. All we're looking for is this. Okay, so now I can find the area of the base. So the area of the base is equal to 1/2 the base times the height equals 1/2. The base was what? 8. The base was 8. The height is 4 times the square root of 3. Or you can still use the square root of 28. So when you multiply these three together, you get 16 times the square root of 3 or 4 times the square root of 48. Notice I'm not plugging in what those square roots are. Why don't I want to do that? Exactly. It's going to be plugged into a formula. Let the calculator figure out what it is. Okay, so now the formula, now that you found the base, now we use the formula for the area of a prism, which is the area of the base times height, this B, area of the base. So whichever way you figured it out, it's going to be 16 square root of 3 times what's the height? Well, we use these three numbers. What's the only number we haven't used yet? 10. That's how you figure out what number to use. We use these 3 8s to figure out the base. The only one left is the 10. So we're going to multiply it by 10. Or 4 times the square root of 48 times 10. Plug either of these into your calculator. This gives you 160 times the square root of 3. Times square root of 3 gives me 277 point that. We want it rounded to the nearest whole number. 270.13 equals 277. This is going to give me 40 times the square root of 48. 40 times 48 square root. Looky, looky, looky. And this question is in, doesn't tell me my units. The book has inches. So my answer is inches